Till now, we have been looking at the properties of images formed by plane mirrors. A plane mirror is a mirror whose reflecting surface is flat. What about this mirror? Is this also a plane mirror? This is a mirror as it has this smooth reflecting surface. But this is not a plane mirror as this reflecting surface is not flat. The reflecting surface is curved and hence this mirror is called a curved mirror. What about this one? This is also a curved mirror. The difference between the two is that the reflecting surface of this mirror is curved inwards, whereas the reflecting surface of this mirror is curved outwards. Can you think of examples where you have seen curved mirrors? A shiny surface of a spoon is a good approximation of curved mirror. Spoon has two reflecting surfaces, one curved inside and the other curved outside. Now the specific types of curved mirrors that we are interested in are called spherical mirrors. In fact, these two mirrors are spherical. Well, they look nothing like a sphere. But then why are they called so? They are called spherical mirrors because their reflecting surface is a part of a sphere. You can clearly see that the reflecting surfaces of both the mirrors form the part of the sphere. Now both these are given special names. The mirror that has its reflecting surface curved inwards is called a concave mirror, and the mirror that has its reflecting surface curved outwards is called convex mirror. Yes, inwards, concave, and outwards, convex. Now we want to study the properties of images formed by spherical mirrors. But before that, we need to define certain terms related to spherical mirrors. So let's do that. Both the mirrors are placed like this: concave mirror on your left and convex mirror on your right. I'm going to define the terms for both these mirrors: concave inwards and convex outwards. The center of the reflecting surface of the mirror is called the pole. We represent it with a point P. In the front view of both the mirrors, you can see that the pole is present right at the center. Now, as I told you, the reflecting surface forms a section of the sphere. This sphere must have a center. This center of the sphere is called the center of curvature, denoted by C. And what will the radius be called? Yes, it's called the radius of curvature. Join the pole and the center of curvature with a line. This line is called the principal axis. The midpoint of the line segment joining the pole P and the center of curvature C is called the focal point. It's denoted by the letter F. We will talk about one last thing in this video. And that is an assumption that we are making all along. We are assuming the radius of the curvature of a mirror to be much greater than the aperture of the mirror. Aperture, in simple terms, is that part of the mirror which is exposed to light. In our mirror, this is its aperture, since the light can be incident anywhere in this region. If we hide some part of the mirror with an opaque substance, then its aperture is reduced. Mathematically, it is this length. So the mirror that we are considering is the one in which the aperture is much smaller than the radius of the curvature. These were a few of the terms related to spherical mirrors. But there's a lot more we need to understand about them. See you in the next video.